All right, open up your book to section 5-2. We're on page 248 in your book. And the title of this section is Measurement of Rotation. And the objective is given an angle of any measure, draw a picture of that angle. So we'll be sketching angles here in this section. All right, let's start out with a few terms that we should know when we're working with angles. Some of these terms might be terms that you already know from previous math courses like geometry. Some of them might be new here for us, but let's clearly define the parts of an angle, and definitely one part of this is probably new for us, and that's listed under that note. But let's deal with how we construct an angle first of all. An angle, remember, is made up of two rays, and the endpoints of those rays they have in common. And that common point there is what we call the vertex. So the vertex is at the endpoints of your rays. And then the two rays, we call one of them the initial side and the other one the terminal side. And the reason that we do that is because our angle, when we go to measure it, will have a direction. Notice that I'm not just simply using a little arc there to indicate that angle theta, but rather it's actually an arrow that starts at the initial side and heads towards or ends at the terminal side. Your angle will have a direction to it. And that's what the note over there on the right says. The angle has a direction. Again, that might be something new for us, that for marking angles in a triangle or whatever it might be, we probably were not in the past indicating a direction to that angle. But now we are going to need to make sure we keep track of the direction that angle is being measured in. So you have an initial side where your angle starts from and a terminal side where it ends. And the Greek letter theta there is just one of the names we'll use to describe our angles there. To name our angles, we'll use Greek letters for many of these angles that we work with. Theta is a common one to use. All right, so when we work with angles, we have something called standard position that we will place our angles in. And basically from this point forward, everything will be considered to be an angle in standard position unless it's noted otherwise. But what exactly does it mean to be in standard position? Well, standard position means that you have an angle that you've placed into the Cartesian coordinate system, and it has three requirements here, three properties that make it an angle in standard position. So the Cartesian coordinate system, that's just simply your Cartesian plane there, so that's your x-axis and your y-axis sketched normally. And we're going to place an angle inside of that Cartesian coordinate system. In other words, we're going to draw two rays where they share an endpoint in order to make an angle for us. All right, so what are the requirements there in order to be in standard position? So the first thing is that you have to place the vertex at the origin. So your two rays start at the origin. The endpoints that your two rays have, they have to share that in order for it to be an angle. And that endpoint is going to be at the origin. The second requirement here to be in standard position means that you're going to place the initial side on the positive horizontal axis. So that's your positive x-axis that we're talking about. So your vertex is again going to be at the origin, and the initial side is going to be headed off to the right there along the positive x-axis. All right, not to the left for the negative x-axis, but the positive direction, so it's off to the right. And then finally, the third piece here to make this an angle that's measured in standard position is the way that we actually measure that angle. And this is why your angle has to have a direction, why it has to have an arrow indicating a direction. And that's because counterclockwise measurements are going to be positive. So as you go counterclockwise, those are positive angles. And if you measure that angle in a clockwise direction, clockwise measurements are negative. So it makes a difference what direction that angle is measured in as to whether or not this is going to be a positive or a negative result. This is why we have to make sure we indicate a direction with our arrow as we're sketching our angles. All right, so let's sketch a few angles here in standard position. So this is an example that they give you here, I guess, on page 248 in your book. They give you several angles there, and we're just going to go through and sketch what these look like. Now, one thing to pay attention to as we go through and sketch these, notice that I'm not going to get out a protractor here and try to measure these exactly. When you first started doing that in your geometry class, that was a natural thing to do. Let's learn how to use a protractor and let's learn how to make these measurements exact, or as exact as we can. Here, we're going to just approximate what those look like, much like when you're working with graphing a function. When you first started learning how to graph, you probably used a piece of graph paper and you plotted points to get as accurate a sketch as possible. And eventually you got to the point where you just draw a horizontal line and a vertical line and call those your x and y axes, mark off some tick marks along your x and y axes, and then kind of approximate where things are at. That's kind of where we're at this point. We're not going to worry about getting an exact measurement here for what 57 degrees should look like. But I should know that 45 degrees is halfway between my two axes. In particular, this is 0 degrees, and this is 90 degrees here. My positive x-axis is 0 degrees because that's the initial side. And my terminal side there, if it ended up on the positive y-axis, that would be at 90 degrees. So I know that 45 degrees is right down the middle there. So 57 degrees is going to be a little bit more than that. So I'm going to draw it kind of like this and say that this is my angle theta. You could either call this theta, or you could write that it's 57 degrees. But notice that my sketch there involves three key things here. I have a terminal side marked as a ray. I have an arc indicating the direction of my measurement, and I've also labeled that. I've labeled it as theta. All right, let's move on to the next one. Theta equals 133 degrees. Again, think about where our axes are at here. If I start out at 0 degrees, because that's my initial side, when I hit the positive y-axis, I'll be at 90 degrees. When I hit the negative x-axis there, I'll be at 180. Well, I know that 133 then is going to be between 90 and 180. And again, if you think about the halfway point here, halfway between 90 and 180 is 135 degrees. So that's actually really close to the halfway point. So when I go to sketch this, I'll try to draw this so it's about halfway through that second quadrant. And when I go to measure this angle, I'm measuring from my initial side, which is my positive x-axis, and I'm measuring a positive angle, so it's in a counterclockwise direction. And again, label that, either call it theta, since that's what it's labeled down below, I can do that, or label it as 133 degrees. Those are the three key things there as we're sketching these angles. Let's try a couple more here. Theta equals a negative 251, so a negative value, got to be careful with that. Again, we start out at 0 here, but if I'm talking about negative angles, that means I'm going clockwise. So if that's 0 degrees, then this must be negative 90 is the negative, or is the negative y-axis, and then negative 180 is the negative x-axis, and then negative 270 would be the positive y-axis, and so 251, negative 251 falls in between those. 251 is a little bit closer to 270 than it is the 180, so I'm going to draw it closer to the vertical axis than it is to the horizontal axis there. So there's my terminal side, and again, since it's negative, I'm measuring from the positive x-axis, and I'm going in a clockwise direction now. So that's my angle theta. Again, name it, along with drawing the arc that indicates the direction along with it, as well as the terminal side. All right, and the last one here is it's a positive 560. So if you start going around your axes here, you'll find out that you've got 0, you've got 90, you've got 180, you've got 270, and when you get back to the positive x-axis, you're back to 360 now, which is what we've got to do, because I've got to go past 360 degrees. In fact, if I add 90 to that, what is that, 450 degrees? Add 90 to get that, that would be 540 degrees, which is close to the number we're looking for. And then down here, this would actually be 630. It would be another name for that angle that would terminate on the negative x-axis, or negative y-axis there. So 540 is close to the 560 there. So it's barely into this third quadrant. So I'd sketch it maybe like this. And because this goes 560 degrees, I got to make sure that my angle that I indicate here is in fact 560 degrees. So it will require that I go around once and then come back around and stop at that angle. So there's a little bit of a spiral you draw there to make that happen. All right. If it turns out you have to go around, we'll see an example of this, but if it turns out you have to go around multiple times here, then we can indicate how many times by just writing a number next to it so we know how many times that is. But let's call this angle here theta. which is 560 degrees. Again, as long as the angle is named for you, you can just write the name of it. If it's not named, then write down the actual measurement there, or name it yourself. All right, so there's some sketches of some angles. All right, we have a couple of special angles then that we talk about. One of those is what we call a coterminal angle, or coterminal angles. And coterminal angles are two angles that are in standard position whose measures differ by a multiple of 360 degrees or share a terminal side. If you think about it in terms of multiples measures differ by a multiple of 360, and that's kind of an algebraic way I could write this down. If I think about it in terms of the terminal side, that's kind of more of a graphical or visual representation of that. And the name that we'll use to describe this will be theta sub c. Theta sub c will be a coterminal angle to angle theta. So what does that mean algebraically? Algebraically, it means that theta sub c and theta are going to be coterminal if and only if they satisfy this little equation here. If you can write theta sub c is equal to theta plus 360 degrees times n, where n is some integer, then theta sub c is in fact a coterminal angle to that. Basically, that's another way of saying as long as you can add or subtract some multiple of 360 from theta, you'll get a coterminal angle to it, is really what this little formula is telling us to do. The other type of angle that we need to understand and work with is what's called a reference angle. And reference angles are the positive acute angle between the horizontal axis and the terminal side for an angle in standard position. And the name that we'll use to describe that will be theta sub r. Well, the book will use theta sub ref. If you want to write it that way, that's fine, but we're going to just use theta sub r. And what I'm going to do here, as well as what you can do in your assignment and in your notes, but just realize if the book you see them using theta sub ref, that they're talking about the reference angle in that problem. Now, there's a lot going on here when you look at this definition. First of all, they say that it's a positive angle. So being a positive angle tells you the direction that it has. If it's an angle in standard position, then that means that it's got to be an angle that's measured in a counterclockwise direction. They also tell you that this is an acute angle. So that means that that angle's got to be somewhere between 0 and 90 degrees. Not equal to 0, not equal to 90, somewhere in between. And then the last piece of this is that they tell you that it's between the horizontal axis and the terminal side. When you look at your angle there, there's kind of two ways you could measure this. One of those, or two angles you can come up with here between the horizontal axis and the terminal side. One will be acute and one will be obtuse. And furthermore, two of those two ways you can measure it would end up giving you a negative angle, and two ways you can measure those two would be giving you positive angles. So this narrows it down to the one and only possible angle that we can talk about. It's the positive acute angle that's between your terminal side and your horizontal axis. One thing to note here about the reference angle is that angles whose terminal side fall on one of the axes, so whether it falls on the x-axis or the y-axis, doesn't really matter, those angles do not have reference angles, and that's because the fact that the angle is not going, the angle is going to either be 0 or 90 degrees that you'd be working with, and it's not acute then. It has to be an acute angle to be a reference angle. So some angles do not have a reference angle. All right, so let's take a look at an example here. Let's let theta equal 133 degrees, and let's suppose we want to find these two things here. I want to find a coterminal angle. Actually, we're going to find a couple of coterminal angles. And we'll also find the reference angle, and then we'll also sketch all these. Okay, so let's start out with an xy axis here. We're going to draw this in the Cartesian coordinates here. 133 degrees, we just sketched this a second ago. That turned out to be in the second quadrant, so it's somewhere about right here. This is the angle, theta, that they're giving us. And they want us to find two coterminal angles. So let's find one that's positive and one that's negative here as our example. Let's take and find a positive one first. We'll say theta sub c is equal to, if you take your angle theta and you add on 360 degrees, I'm going to basically let n be 1 here. In fact, if you want to see it written that way, I can put in parentheses times 1. From that little formula that we had a second ago. So if we do that, theta is again 133. And if I add 360 to that, adding 360 to that gives us what? 493. So 493 degrees would be a coterminal angle with this. If I want to sketch this on the same graph here, there will be a lot going on here, but I'll try to sketch it. 493 means, again, it has to start at the initial side here, so it starts here at the positive x-axis. It goes all the way around once, and then ends at that terminal side. All right, this is a 493 degrees. Since I'm going to have a couple of coterminal angles, I'm just going to use the number here to indicate it rather than writing theta sub c there. Let's do another one here, but let's do this in a different color. Let's find another coterminal angle. This time, we're going to take theta, and we're going to add on 360 times a negative 1. I'm going to let n be negative 1, or in other words, I'm subtracting 360 from theta this time. And let's see what we end up when we end up with 133 degrees minus 360 degrees is what we've got there. So if you take 133 and you subtract 360, what do we end up with? Negative 227. Negative 227, I think, is the number we end up with. Double check that. Negative 227. So what is that angle? Well, that's negative, so that tells me I'm headed in a clockwise direction. And it's going to be between a negative 180 and negative 270. Again, that's in the second quadrant. That's not quite the angle we sketched before, but it's close to it. That would be this angle right here. That's a negative 227. Okay? All right. And the last thing that they want us to find here was a reference angle, or not a, but the reference angle. Let me do that in another color here. So our reference angle depends on what quadrant you're in as to how you calculate your reference angle, but our reference angle would be the angle that's between your horizontal axis and your terminal side. So there's really only two angles to mark here that I'm going to sketch or mark both of these. You could have this angle right here between my terminal side and my horizontal axis, or you could have this angle right here between your terminal side and your horizontal axis. Now, it says that it has to be an acute angle, which means it eliminates the one that's over on the right. I'm going to go ahead and just erase that, get rid of it. So it can't be that one. And then further, it says that it's got to be positive, so that tells me the direction. So when I mark this, I need to indicate that it's going in the counterclockwise direction. All right? So there's the angle marked. The question is, what is that angle equal to? Well, if you look at the initial side and the terminal side and where those are at in terms of our angle, the terminal side would be the angle of 180 degrees. That's the terminal side. The initial side of our angle that we've got marked there is 133 degrees. So the difference between those two, just take your final minus your initial, or your terminal minus your initial. That would be equal to 180 degrees minus 133 degrees. And what's that end up giving us here? What, 47 degrees it looks like, right? 47 degrees is our value that we come up with. It's not always going to be 180 minus the angle that you're given, though, to find your reference angle. It varies depending on the angle. So you got to look at the graph or look at the sketch of it and help yourself figure out what the calculation is. But it's always going to be the terminal side minus the initial side there in terms of the reference angle that we've got marked. And let's go ahead and name that then. I guess I'll have to kind of write over top of this, but it's in the right color here at least. Theta sub r is that angle then that we've got marked there in purple. Theta sub r, 47 degrees. All right, take a look at example number 1, which has us finding some angles, actually sketching and calculating some reference angles here. So a little bit more practice here with sketching angles. So the first one here is theta is equal to 71 degrees. So 71 degrees, I know this is 0, I know this is 90. So 71 degrees is going to be somewhere about right here. We'll mark that angle. and call it theta. Now that's the first thing they want you to do is sketch this, and then the second thing they ask you to do is calculate the reference angle. So I'm going to go ahead and mark the reference angle. Again, there's only two angles you could possibly mark here. There's this angle right here on this side, between the terminal side and the reference and the horizontal axis. Or you can mark this angle over here, but again, that's not acute. So I'm going to erase that because I don't need that one. That's the wrong one. And it has to be in a positive direction, so that means it's got to be counterclockwise. What you'll notice with this one is that your reference angle and your terminal side there are the same. Your original angle and your reference angle are the same. This is theta sub r. So in this case, there's really no calculation to do. But if you wanted to think of it as a calculation, just think of your terminal side of this angle that we've got marked is here at 71 degrees. And our initial is the 0 degrees. So theta sub r is really 71 degrees minus 0 degrees, or that's just 71 degrees. All right, if you're in the first quadrant there and your angle is between 0 and 90 degrees, turns out your angle and your reference angle are the same. All right, what happens if we jump to the second quadrant? 133 degrees, we've, I guess, sketched this one now a couple of times. But 133 degrees we know ends up being in the second quadrant. Again, this is 0 degrees, this is 90 degrees, this is 180. If it helps you to write those angle measurements down so you get yourself in the right quadrant, then do so. Here's our angle theta. So there's our sketch of this angle. And now for the reference angle is going to be this angle right here between the terminal side and the horizontal axis. Again, there's only two that you could mark here. Theta is actually one of those two that I've already got marked, and this is the other one. But theta is obviously obtuse, so it can't be that one. And I have to give it a direction, so it's got to be in a counterclockwise direction. We've got it sketched here correctly. Now the question is, what's it equal to? Well, theta sub r, we actually already did this in the previous slide there, I guess, really. But we'll go ahead and calculate this. If you take 180 minus the 133, that gives us 47 degrees. There is our reference angle. All right, 254. So if our angle is 254 degrees, again, this is 0, this is 90, here's 180, and 270. So that means that we are in the third quadrant with this. And 254 puts us closer to 270, so I'm going to mark it down here. Here's our angle theta. And so now your reference angle. Your reference angle then is always the angle between your horizontal axis and your terminal side of your angle. So again, there's really only two that I could mark here. I could mark this angle right here, or I could mark this angle right here. But again, it's got to be the acute angle, so it's the one that's on the left. So let me undo that or get rid of that one. And then it's always positive, so that means it's got to be measured in a counterclockwise direction. That right there is theta sub r. Okay. And so now what's the reference angle equal to? Again, to calculate your reference angle, just think about where the terminal side of this angle that we've got is at. So this is at 254. And the initial side of this angle, the reference angle that we've got marked, is at 180. So the difference between those, 254 minus 180, gives us the reference angle. So what is that? 74 degrees. It's positive, it's acute, looks good. And let's do one last one here. Last one here, probably can guess that they gave us a problem here that was started off in the first quadrant, the next one second quadrant, the last one we did was in third, so it's probably not going to be a surprise what quadrant we're in here, but let's just verify that that's the case. Here's 0, here's 90, 180, 270, and then back to 360 here. So yeah, between 270 and 360 is our angle. That's the fourth quadrant. And halfway between 270 and 360, that would be what, 315? And we're at 317. So we're just about halfway through this. Actually, a little bit more than halfway. That wasn't quite halfway like I wanted to sketch, but that's close enough. And we end up with this angle right here as our angle theta. Again, mark your angle first of all, and then they want you to mark your reference angle. And again, to mark your reference angle, there's really two angles you could sketch between the horizontal axis and your terminal side. It could be this angle right here, or it could be this angle over here. But again, you want it to be an acute angle, so it can't be that one that I sketched on the left. Let me get rid of it. And it's got to be a positive angle, so that means it's got to be measured in a counterclockwise direction. So indicate an arrow on that as well. And that right there is theta sub r. Theta sub r, our reference angle. And so now, again, to calculate your reference angle, you always think about that angle that you've got sketched there. Think about where it ends. It ends at 360. That's the terminal side of that angle. It starts at 317 is the angle that gets me there. So the difference between those tells me my reference angle. 360 minus 317 degrees. And that gives us, what, 43 degrees. It's positive, it's acute. That looks like we've got ourselves a reference angle. All right, let's take a look at one last example here. They want us to sketch a really large angle now. It says sketch the angle of theta I'm going to call it theta. I guess they didn't call it theta, but theta is equal to 4,897 degrees. Theta is equal to 4,897 degrees. All right. They say sketch the angle and then calculate the measure of it. All right. Well, 4,897 degrees. Hopefully, we can figure out right away that this must wrap around multiple times. This is going to have that spiral effect when we go to sketch this thing. Let's go ahead and grab our calculator and find out how many times it wraps around the coordinate system here. So grab your calculator. All right, so with your calculator, all I want to do is find out how many times this wraps around here. Basically, I want to find out how many times 360 degrees goes into this number. So if you take 4897 and divide it by 360, we end up with 13.6. I'm not worried about the decimal part to it. It's the whole number part that I want to see. So that's 13.6. So let me use that to help myself sketch this. That's the first thing I'm going to do is sketch it. So when I go to sketch this, here's my coordinates here. I guess I actually need to do a little bit more work with that number, don't I? Let's first write down the calculation that we came up with here. If I take the 4897 and I divide it by 360, I found out the quotient. It's 13. What I need to find is I need to do some integer arithmetic with this or integer division with it and actually find the remainder as well. So I didn't quite calculate that, so let's go back to our calculator and do that. So if 360 goes in there 13 times, what I can do is I can take the 4897 and I can subtract 13 times 360. And that'll tell me the remainder part of this. That's the number I needed. So it's 217. In fact, let me just grab a picture of this. And we'll put it in our document here so we have that calculation. All right, so now we know that this is equal to 13 with a remainder of 217. The 217 is critical because I need to know what quadrant this angle is going to terminate in. So 217, that's between 180, this would be 180, and 270. So I'm going to terminate in the third quadrant. And it's going to be, well, almost halfway through this angle here, or in this quadrant, I guess. 225 would be halfway through. So this is how our sketch will look. We'll sketch ourselves a terminal side to this. And then to sketch your angle, I'm just going to do this in a different color this time just so it's easier to see what I've got here. But you can start drawing this going around here. You don't have to draw it going around 13 times unless you really want to. But instead what you can do is you can say times 13 to make it clear that you're doing that 13 times as the sketch you're trying to draw there. That right there is our angle theta that they gave us. Okay? All right. That was the first part, was sketch it. And then calculate the measure of the reference angle. All right, so we had to calculate the location of the terminal side here with our calculation that we've done already. But I have not calculated the reference angle. Again, if you sketch your reference angle, that would be this angle right here, the angle between the horizontal axis, your x-axis, and your terminal side there. That right there is theta sub r. So let's go through and calculate what theta sub r would be equal to. So theta sub r, I'm going to use my calculation that I've done here to help me find out what theta sub r is equal to. That is, I don't want to use the 4,897 degrees, but rather I want to use my remainder of 217 degrees. I need to get this down to an angle between 0 and 360 to do my calculation. So that's the first thing to do. By the way, what we found there is that 217 degrees is a coterminal angle. Maybe we should write that down. Theta sub c is equal to 217 degrees. In our equation there, if you take and let n be a negative 13, we'd get 217 as a result. So that's what we're working with here, is actually the coterminal angle that's between 0 and 360. But I want to subtract off 180 degrees from that, and that should give me my reference angle. So what do I end up with? 37 degrees, it looks like. 37 degrees, it's positive, it's cute. That looks like the right calculation there for our reference angle. And that's the end of this section here, section 5-2.